Hello, this is my car savings jar lesson. I had students develop and explore volume by creating their own unique 3D solid. And it's really relevant for the students because most students in my 10th grade honors geometry class range from 14 to 16 years old. So all of them are really excited about getting their driver's permit or their driver's license, and they're ready to buy their own car or start driving their own car. So inside the lesson, I had students take a pre-assessment on Google Forms, and this helped me determine the differentiation that I needed for my task. Students developed their own 3D jar with at least 3 unique solids using 3D GeoGebra. Students calculated volumes and considered if saving dimes or saving quarters would make more sense when using their unique jar, and they posted their project on an entire class Google Slides presentation. They created a screencast of their work and embedded that screencast from YouTube into the Google Slides presentation, and commented on 3 classmates' posts and determined how they could alter their classmates' jars to increase the volume and the amount of money saved. And ultimately, they took a post-assessment, and this helped me show if students mastered those volume standards. So the technology tools that I used was Google Forms, GeoGebra 3D, screencasting, and Google Slides. So some examples of those, this was the Google Forms assessment that I used. So it had basic volume questions on it, and then it went to some more complex questions where students really had to show me that they understood how dimensions changed volume. But what I really want to show you is this quick spreadsheet that I created, and I used a Google spreadsheet add-on called Flubaroo. So Flubaroo grades assignments based on a key that you choose, and it shows you deficits. So these orange little slides here, these orange columns, they show you where students struggled with those standards. And this also helps you with differentiation and also for reteaching purposes. They used a 3D calculator on GeoGebra, so they created these 3D solids. So they could use any type of solid that they wanted, just wanted 3 different ones. So they could use a pyramid, a cube. But what's really cool is they could explore how the solids changed and how that changed the different dimensions for volume. They could rotate, they could make things bigger or smaller. But the really cool feature with GeoGebra 3D is that it quickly calculates using this measure tool function. It quickly calculates side length, and it can also calculate volumes really quickly so that they could check their work. So this is kind of a feedback piece where they could actually check to see if they were doing what they needed to correctly. So students were encouraged to use Screencast-O-Matic, and the reason is because once they launch the free recorder, since they already have a YouTube account from their Google account, this site is really easy for creating a YouTube video. And from that, they could easily embed, and they can also easily include the link in their actual presentation. So for the presentation, we had multiple students here on the side here with their car savings jar. So here's another example of a car savings jar. They had their volume calculations and creating a thesis based on the coin that they thought saved more money. But the cool thing about GeoGebra or the Google Slides is the commentary section. So students could see their different commentaries for their classmates, they could reply to them, and they could talk about the terminology needed, so what they would need to change in the dimensions to change the volume. So this was a good way for students to collaborate. So overall, this was the rubric that I used to grade. I had the jar creation, the GeoGebra requirements. I didn't allow students to exceed 15 by 15 by 15 because I really wanted the students to think outside the box and actually inside the parameters to make the biggest shape that they could. I had the volume calculations and the justification piece. I really wanted students to focus on that mathematical terminology in their justifications, both for their actual screencasting presentation and for the feedback that they gave their peers. So some of the challenges that I had is some students struggled with using GeoGebra at first. Many students did not try their best on the pre-assessment. So they see pre-assessment, they think, oh, this isn't a grade. And that really hurts me because I'm trying to differentiate the instruction, but if they don't try their best, then I'm not necessarily seeing exactly what they know. And some students struggled with the terminology piece to justify their work. So in math class, they're not always asked to say, why is this happening? Why is this happening? But the shift is towards that. So just helping students develop that language would be better. But some really cool things happened as well. So students were able to learn at their own pace. So based on that pre-assessment, I differentiated the instruction, provided videos, students could learn on their own or one-on-one, and students could explore instantaneously the changes in the dimensions, so like changing those GeoGebra sections and how that actually altered the volume. The commentary led to different perspectives and a better conceptual understanding, and students were able to develop something on 3D GeoGebra that they thought was kind of cool. So students were able to collaborate with their classmates, so the collaboration piece really helped them develop how different students think and understand different perspectives. So I think the lesson could have been improved. So I was thinking one other way that would have been really cool to explore is that some of the Hispanic students in my class, they had told me that they travel for Christmas, they travel back to Mexico. And I thought about, well, what if we talked about different currencies? Could a different currency and different coin sizes from different currencies affect the amount of money saved? I also think that allowing students more time to explore GeoGebra 3D would be better, and setting those expectations for what needs to be included in the Google Slides presentation and the screencasting presentation. I think ultimately I would allow more time for the lesson. It seemed like I needed another 1.5 days for the lesson for students to really show me the mastery. And then also, some students struggled with the algebraic. I assumed that students understood algebraically how to plug in different dimensions into a formula, but just kind of going over that and making sure that I have built-in instructional time for that to ensure that they understand the volume and calculations from the volume. So that is my car savings jar lesson.